Greetings. I'll be talking about exponents and logarithms. So as for exponents, is in the form of a to the power of x, where a is more than 0. This is because if a is less than 0, to put it negative, then eventually there is no pattern due to the alternating positive negative values. Okay, so a is the base, x is the power variable. A to the x is more than 0, mainly because all of them will be positive numbers. Indices are numbers where x is an integer such that a to the power of x is a times a times a to whatever, how many base numbers you want to multiply. If a to the power of 1 is just equal to a, because you're just using a, 1a only. If the base a is in between 0 to 1 or a to the power of negative x, you get a decaying graph. The common base used is either 10 or e. Now we are going to look into the laws of exponents or indices. As you can see, the law of indices include the product law, the quotient law, the power 0 law, the power to multiply by the power, inverse or reciprocal exponents, and radical type exponents. As such, all of these can be attained via proof, and you need to make sure that you thoroughly understand all these laws. You can use the examples like, let's just say a squared times a cube, times these both together and you get a to the power of 5. a cube divide a squared will result in a, and this is how you understand the laws of exponents or indices, since that can help you understand the laws of exponents, which will be used to prove for the law of logarithms later on. Now I will explain about logarithms. So logarithms is usually in the form of log base a x equals y, where a is more than 0 and not equivalent to 1. X is more than 0. This is because if all of these conditions are not fulfilled, then it will result in a math error due to some circumstances where it is undefined. When it comes to log exponents, log and exponents are related to each other, such that logarithm is the inverse of exponents, and due to this nature you can interchange logarithm and exponent. If log base a with a is equivalent to 1, this makes it useful because you can just make log appear, and it comes from the fact that a to the power of 1 is just a, so you can use this to make log appear and solve in your logarithm calculations. Do note that log 10 is a common logarithm, where ln is a natural log. You can mention it as log base e, but common ones use ln. And exponentials and logarithms, they are connected. Now I will explain the laws of logarithms. Notice that on the right in the white box, the first one is the product law, the second the power law, the third quotient law, and the fourth the reciprocal law. So as for these four logarithm laws, you just need to use the law of exponents, and you need to use two equations such that it creates the fact that two equations and are linked together, and that you can use logarithms to solve. It result in the first and third laws. The fourth law evolved using the power law, where you take a to the power of m raised to the power of n, and then you solve from there. As for the reciprocal part, this one is pretty self-explanatory, because you can use the power law, or you use the quotient law to find it. And if you look on the right, outside the white box, this one results in the fact that a raised to the log of whatever number you have will result in that particular number. This is because the logarithm of that base will cancel that out of the exponential base, resulting in the number that's inside the logarithm output. Now, I will explain how the base change works. So base change is very useful, and all you need to do is you convert the logarithm into an exponential equation, and then you log both sides, make sure the log is of both sides has the same base, and then you use the power law to do so, and then you make it into a fraction, and then you replace the variable with the original logarithm you started with. Therefore, this will give you the base change formula, and this is highly useful because if you want to change from one base to the other, you just need to do that, and all you need to do is just prove it. So that is all for this video. I really thank you for watching it. If you really found this helpful, you can share it with your friends who are struggling with this chapter.